Alright, welcome back. So besides the query we showed before, another important operation we need to do with this index is to the insertion and deletion, right? Because if we have query on some data records we have never put into index table, then we probably need to insert them into the index table instead, right? So in this page we show you with the example for the tree insertion. Let's assume we do the query on some new data records like X, and we plan to insert this X into the index table as well. So next time if we do the query based on X, then we can return the pointer to X directly, right, from the index table. So then the question will be, how can we do the insertion into the tree, into the index? And so we have provided this and we have provided our tree we construct already, and the new X we plan to insert is like this one. This X is a new X, and it is also a rectangle, and we plan to insert it into this R tree. Then how can we do this? So to insert it, probably the first step we need to do is to find the right position, right place for us to insert this X, right, in this R tree. In other words, we need to decide its position, which area this X should belongs to. So from this diagram, we see this X should belong to this R1, right? And also belongs to it seems belongs to this R3 because it has a majority overlap with R3. Then how can we find the overlap with this R3 in this R3 structures in the computers? So the process will be very similar. We also find we want to do query, right, for this X first. We query for its position first, and the query process is very similar to the one we showed before. We check this R1, R2 one by one to see which area this X should belong to. So we check R1 first. We know this X belongs to R1, right? It has overlap with R1, and for R1 we can further check R3 and R4. And so in other words, we can go to the lower layer, and besides R1 we can also check R2, right? Here we know this X has no overlap with R2 at all, right? The R2 right now. However, if we plan to incorporate this X into R2, in other words, we have to update this R2 to a larger rectangle instead, right? So for the R1, if we plan to incorporate X into R1, then we don't need to do any operation on R1 at all, right? However, if we plan to incorporate this X into R2, we have to enlarge this R2, so we can include this X into it, right? If so, then we will have some problems because this R1 and R2, they have lots of overlaps. And this D and A, they should also belong to both R2 and R1. It will be a problem, right? In other words, if we plan to incorporate X into R2, it should be a very bad idea. And we will continue with R1 directly. And for R1, we have two small side rectangles. The first one is R3, and the second one is R4. Before we have R3, which is relatively smaller, right? Because we still have one part of X which doesn't belong to R3. If we plan to put this X into R3, we'll probably have to enlarge this R3 as well. And we can draw a larger R3 instead, right? It should be okay, if we do enlarge this R3. However, if we plan to incorporate this X into R4, we probably also need to draw a larger R4 instead, right? So it can incorporate or cover its X as well. Then the question will be, which one should we decide? Should we choose? Shall we put this X into R3 or into R4? So according to the diagram, probably we can put this X into R3, right? Because we just need to enlarge this X slightly, and we can have put this X inside it, and we can put this X at this position, and so we can ensure this X will be covered in R3, and also the node degree is still inside the range, right? Because we have two parameters for the R3, the lowercase m and the capital M, right? Alright, so we can find the right position for the X record, and we can put it into R3 and also add it to the end of this leaf node. Alright, and besides this, if we plan to further insert a new one like a Y this record into this R3, how can we do this insertion? This process will be very similar, right? We plan to insert into this R3, and we can find the right position for Y first. We know this Y probably should belong to this R4, right? And going from the root, we search one by one by one layer. We can go to this node, and we should insert this Y into this node, this leaf node, right? And we can put this Y inside it. However, right now this node has 3 records already. If we further will insert y into it, the entry inside this node will be 4, right? And it will violate the parameters we defined before for lowercase m as well as uppercase m. We need to ensure the records inside the node should be less than 4, for example, right? If so, then how can we deal with it? If we insert this y into its position, right, we find this node has 4 records, then we probably have to split this node into 2 parts instead. For example, we can split these nodes into 2 parts. The first part is a dy with 1 empty entry. This is a new leaf node. And the second leaf node we have is ef. We have 1 empty entry in the leaf node. So we can create 2 new leaf nodes by splitting the original one into 2 parts, dy empty, ef empty. And however, here we have R4 before, right, for the parent node. Right now we have 2 new nodes. This is R4 prime and this is R4 prime, right? These are 2 new nodes we create here. And we have to insert them to replace this R4 we have before. And right now we have 2 entries, R4 prime, which is this rectangle, and R4 prime, which is this new rectangle, right? Alright, so in this way we will be able to insert this y into the tree as well. We have to do the splitting of this node, and we also need to handle the parent node as well because we have some new records of the leaf nodes which are created here. Okay, so this is the insertion, and we can show you these 2 examples to illustrate how we do the insertion into this R tree.